Ever wondered why the reset and clock control, or RCC block, is so crucial in microcontrollers? Well, today we dive into the heart of the STM32L452 series from ST Microelectronics to find out. The RCC block acts as the command center for managing system and peripheral clock signals, controlling resets and power management. It's like the conductor of an orchestra, ensuring all parts play in perfect harmony. The first feature we explore is the clock sources. The RCC block provides options to select from a range of clock sources. You have the high-speed internal, high-speed external oscillators, and the low-speed internal and external oscillators. Just like a good conductor, the RCC block allows the microcontroller to use these sources as the system clock or as clock sources for peripherals. Next up is the phase-locked loop, or PLL. With the RCC block, you can configure and enable PLLs for clock multiplication. This feature is like the magic wand of the conductor, generating higher frequency clock signals from selected sources, and enabling the microcontroller to perform at higher clock speeds. The system clock configuration is another impressive feature. You can configure the system clock to be sourced from any of the clock sources, optionally passing it through the PLL to boost its frequency. This clock acts as the main source for the CPU and peripherals, like the heartbeat of the microcontroller. Now let's talk about peripheral clocks. The RCC block offers the ability to configure the clock sources for individual peripherals. These clocks can be divided by different factors to control their operating frequencies, ensuring each part of the orchestra plays at the right tempo. The RCC block also manages low-power modes. It allows for the control of clock gating and the behavior of clocks in low-power modes to minimize power consumption, just like a conductor knowing when to lower the volume to create a calm effect. Reset control is another responsibility of the RCC block. It oversees the reset and control signals for various parts of the microcontroller, controlling reset sources and priorities, and enabling or disabling individual peripherals during the reset process. Finally, there is the clock security system, a feature that detects clock failures and triggers a reset or other actions if the clock source becomes unreliable. This is the conductor's ability to sense a discordant note and swiftly correct it. In summary, the RCC block in the STM32L452 microcontroller from ST Microelectronics is a critical component, acting as a conductor to ensure all parts of the microcontroller work in harmony. From managing various clock sources, configuring PLLs, controlling resets, and managing power, the RCC block is the maestro of the microcontroller orchestra. So next time you're working with a microcontroller, remember the importance of the RCC block and how it shapes the performance of your device.